Hello everyone, welcome back to the Hello World Guy, and this is the second episode of the first person shooter. And in this video we are going to make the movement of our player. So let's get started quickly. So as you can see, I have got my Unity 3D scene loaded up here, and my player is just right there, and I can select my player, and we can start adding the movement logic to him. So the first thing we need to decide upon is the method we will use for the movement. In Unity you can basically do two approaches. You can either do a physics-based approach with the rigid body component, or you can use a non-physics-based approach with the character controller component. Now we are going to use the non-physics based approach because the physics based approach is, while it's realistic, it provides physics of course, but it's quite complicated to program, and that's the reason we are not going to use that, and we're just going to use the non-physics based approach. And for most projects you probably don't need physics, so it's just convenient to use the non-physics based approach, and it's quite a lot better for most cases. But of course that depends on your game and the actual game you're making, and for our game it's better to use a non-physics based approach. So I'm going to select my player, and then we're going to start adding the movement components to it. So first component is the character controller component, which is a really handy component. And as soon as I add that, what you should see is that we have got a collider here. Now this character controller adds a capsule collider automatically, and that's pretty good. But it also gives us a bunch of other settings and handles a lot of movement automatically. So that's pretty awesome. And you can change the size, the radius, and the height of the collider here, but I'm going to just leave that at the default, and we are not going to change any of these settings for now, at least. And I'm just going to reset. Okay. And then we are going to go under here in this add component option, and then we are going to create our own script. So I'm going to just go under first I'm going to just create a script inside of our script folder. So I'm going to go under scripts, right click, create a new C# script, call it player movement. Then after doing that, I'm going to select my player, hit add component, and add the player movement. Okay, let it compile. Okay, and then I'm going to go under add component and add the player movement that we just created, and then I'm going to double click to open it up inside of Visual Studio. So now as you can see, Visual Studio have loaded up, and I'm going to remove the first two using tags, and then now we can start programming to program the movement logic. So I'm going to first of all get a reference to our character controller. So I'm going to create a private character controller called controller, and then for in the start method I'm going to say controller is equal to get component character controller, and then in the update method we can do something like we can actually use a controller to move our object. So just to give you a small demo, what I'm going to do is say controller dot move, and this move method takes a vector 3 for a direction, and basically not only a direction, actually the whole motion, and then it takes a vector 3 and it moves it based on that. So I'm going to say new vector 3, and here we are going to supply it with three values for an x, y, and z. And as you know, z is the forward axis, so I'm going to say 0, 0, and 1 to move it on the z axis. Now this is obviously going to be very slow because that's a small speed. So I'm going to go up here, create a serialized field. It's going to be a private float movement speed, and it's going to be I'm going to just set it to something like 7. And here we are going to multiply this new vector c that we have created by the movement speed. And this is not really correct because this update method of course runs at a variable frame rate, so this is going to be frame rate dependent. So we need to make it frame rate independent, we are going to multiply it by time the delta time, and that should be fine. Now if I let the code compile, and then I open up Unity, and if I hit play, then our player should start moving forward. So if as soon as the game starts, you can see that our player is kind of moving forward, and he's actually moving towards a positive z axis, that you can see it's kind of working. So I'm going to stop it and then go under Visual Studio. So now here we can start adding the actual movement to our game, the actual movement using player input. So I'm going to create a float inside of this update method. I'm going to call it horizontal, and then I'm going to use it to set it to an input axis, which you can which you remember we can get through input.get axis, and the axis name is going to be horizontal. So we are going to do that, and we are going to just use it like that. And I'm going to create another float variable called vertical and set it to input.get axis vertical. Now what these axes mean? Well, the horizontal axis is basically the left and right, or the A and D keys, while the vertical axis is the up and down, or W and S keys. So here I'm going to, for the Z axis, I'm going to supply it with the vertical variable, because that's forward and backwards movement, and for the left and right movement, for the X axis, I'm going to say horizontal. Now this seems like it's going to work, but if I actually open up Unity, let it do its compilation, and I hit the play button, then you can see that if I hit W, then our player moves towards, well, it moves towards the positive Z axis. You know, the rotation of the player is not taken into account when moving him, which is kind of bad, because of course we want to move the player according to its rotation. So how can we do that? That's actually really simple to achieve, and not really that, but it's not that difficult. So we can basically use a property here called transform dot forward. So what I'm going to do is replace this new vector 3 by, I'm going to just add a pair of brackets here, and here we can say you can use a variable called transform.forward, which returns as the vector that points to the forward direction of this game object. And I'm going to multiply this forward direction by the vertical variable, and then to this I'm going to add, so this transform dot forward multiplied by vertical, this gives us our this is our movement on the Z axis, or not really on the Z axis, the local Z axis, which means in accordance with the player's rotation. And I'm going to add to it transform dot right, which is the right, it's like the right of the player, and I'm going to multiply this by the horizontal axis. Multiplying this whole thing by movement speed at time with delta time, and then moving the controller by that should be all we need. So if I let compile, go under Unity and hit play, then hopefully everything should work out fine. And if I move around, and as you can see, we can move around easily and everything is working. So of course, one thing you probably noticed is that the gravity is not really functioning, but that's really not that much of a problem for our game, and gravity is not that difficult to implement. So that's the thing that we are going to do next. Okay, so how are we going to program the gravity? To do that, I'm just basically going to open up our script, and here we can well, first thing I'm going to do is go here and declare a new class level variable, a private float, and I'm going to call it y movement, or y, I guess, or I just call it something. And actually no need to initialize. So what I'm going to do in the after this move call, I'm actually going to separate the vertical movement into a separate move call, because we are multiplying this by the movement speed and that by time, the delta time. So it will make it kind of complicated to add the vertical movement to just this statement. So I'm going to just add a separate statement here, controller dot move, and I'm going to, for the motion, I'm going to use one called transform dot up naturally, which should give us the up direction, and I'm going to multiply this by our move y variable, and then of course multiply this whole thing by the time, the delta time. That's very important, and this should actually move our player up by whatever value we have got in this move y variable, which by default is 0. So currently nothing should change. Now we are going to actually set the move by variable to something. So to do that, I'm going to go here, and I'm going to go in and declare a variable here. So I will actually, all right, accidentally. Okay, so I'm going to create one variable here somewhere. Okay, that's good. Maybe I should make it explicit, I guess. Okay, so anyways, that I'm going to do here is I'm going to create a I'm just going to create a public constant here. So I'm going to go public const float, and this is going to be called gravity, and this is going to be equal to negative 9.18, I guess. I'm really not sure what it was. Actually, I think it was negative 9.18. Correct me in the comments if I'm wrong. But anyways, I'm going to set that to our main gravity speed, and what I'm going to do here is, and of course we are doing negative because we want the player to move down. So we are going to say move by plus equal the gravity, and that's it. We don't need to do that anything else. So we are adding gravity to move by every frame. Now of course this will keep moving our player down. So if I actually go under the scene and I hit play, then our player should start continuously moving down. Actually he doesn't seem like, okay, he does, but the reason it was not happening was because we were standing on the, okay, so it works as you just saw. So if I hit play, then you can see that our player kind of goes down to this plane, and we are standing on it, but as soon as I go off it, I go down at an extremely fast speed. Why is that? Well, because we keep adding the gravity to the variable, because every frame, and then when we move, and since we have got the ground underneath ourselves, we can't move through it, and as soon as I move off the ground, then we go down at extreme speed. So I'm going to go under Visual Studio back again, and here we are just going to do a really simple check here. So I'm going to say if, so after adding the gravity, I'm going to say if controller dot is grounded, which will tell us if the controller is standing on the ground, and if that is so, then we are going to say move y is equal to 0. Okay, so if I go back into Unity and hit the play button, then you can see that if I move, it's working, and if I do down, then it's still way too fast, as just so. So why is it this fast? Is there anything we can do to, because that's really not how natural gravity is supposed to be like. And since we are in our code, we are actually using the correct value for gravity, then this can't possibly a problem with that. So what's the reason for this? Now the reason is that and it's a little complicated, but gravity is an acceleration, and for that reason we need to multiply it by time dot delta time twice, and we are only doing it once, as you can see when I am multiplying. So when you are going controller dot move, I'm saying transform dot up multiply by move by, and we are multiplying once by time dot delta time, but we need to do that twice. So I'm going to multiply this, but we only need to do that for the gravity. So when we are setting the gravity, I'm going to multiply this by time the delta time in here. Now if I do that and I go under Unity, let it compile, then we should have a natural gravity system. So if I just let it compile and I hit the play button, then what you should see is that if I go off, then I fall down in a natural manner. That's pretty good. So now we can add jumping because the gravity is working. So now we can of course add jumping. So in order to do that, I'm going to go here inside when we are doing this, and I'm going to say if and I'm going to say if input dot get get button, and now this get button function allows us to give a virtual button name instead of a like get key, which allows us to give a key code. Then we just use get button, and we are going to use get button down to only get the button once, and the button name is going to be jump, and I think that it's already set up in the project settings as spacebar. So if we detect that, then we basically need to set the move by variable to something. So what do we need to set it to? We can set it to a predefined force, but I want to determine a height that we want to reach when we jump. So if I go under here, I'm going to go ahead and create a serialized field, a private float uh, jump height actually, and I'm going to just set it to something like 8, something like 6. We can always modify the serialized field in the inspector later, and here we need to set it, we need to make it so that our move by variable is set to a value that allows us to jump jump to that specific height correctly. So to do that, we can use a formula which is basically like this. So if we use math, we need to take the square root of gravity multiplied by what was it now? It's kind of, I can't remember it, but I think it was gravity multiplied by the jump height multiplied by negative 2f. I think that this was it. I am not completely sure though. Starting. So in order to add jumping, what I'm going to do is add an if condition in here, and I'm going to say input dot get button, which allows us to give it a virtual button name to instead of a key code, we can provide it with a virtual button name which we have set up in the project settings. And I'm going to the button name is jump, which is already set up as the spacebar key. So if I do that, and in here we need to basically set our move by variable to whatever we want. Now we could set it to a predetermined force, but I don't want to do that because we want to have a specific height that we want to jump to, and then the code should automatically calculate how to jump to that. So I'm going to say I'm going to create a private float here called jump height, and this jump height is going to be something like I can just going to set it for 6 for now. And in here we are going to use a formula to calculate how to actually jump. So the formula is really simple. Actually, we can just take the square root of, so I'm going to go math f dot square root to get the square root of and for the value we are going to take our gravity. So the actual gravity we have multiplied by the jump height multiplied by negative 2, negative 2. So that should work. So if I take this and let it compile, go under Unity, hit play, then it should be working. So if I hit the space bar, then you can see we jump to a specific height, but you can see we can also kind of jump infinitely if I just keep tapping the space bar key. Also, if I just press, if for example I fall down and I press the space bar key, then I kind of start to fly. So in order to fix that, the first problem and the second problem, we are going to say input.get button down, which will only trigger when the button is pressed. So in the frame the button is pressed, it will trigger, but then it will not trigger if the user is just holding the button down. So if I run the game now, it should be a bit better. And if I this, then you can see, but if I hold the button I cannot fly, but I can still hit the button again and again and again to kind of jump infinitely. So how can we solve that? Well, it's really simple. We can just add another check here that sees if the controller is grounded, and if that happens, we only want to jump if we are on the ground. So yeah, that should pretty much do it for us. If I go in here, hit the play button, then you can see it's pretty much working. We can only jump when we are on the ground, and this is all right, but I think that the gravity feels a little slow because well, our player currently just has a mass of 1, which is obviously very slow. So what I'm going to do is go under Visual Studio, and then I'm going to create a serialized field above everything, and this is going to be a private float, and I'm just going to call it mass, and then I'm going to set it to something like and by default I'm just going to leave it at 1. And here whenever we are doing gravity, we are going to multiply that gravity by mass as well. So here we are going to multiply by mass, and also here, and yes, that's good. And if I go under Unity, then I can select my player, and I'm going to set the mass to something like 2, and it should feel a lot more a lot better. So yeah, you can see it's kind of a lot more snappy, and you can play around with these settings to your reference. I can increase the jump height, and you can jump really high. And oh, just to show you something, if I hit play and I got my player selected right now, and you can see that the y of the player is currently 1.13 and the jump height is 6. That should, if I jump, then it results in around 7, which is correct, because that's if you add 6 to 1, then it's kind of like 7, and it jumps around to around that value, which means that our formula is perfect. And if I go off the ground, then I cannot jump again, and it kind of just falls. So yeah, with that we have got our character controller done, and in the next video we can create the shooting mechanics. So stay tuned for that, and I will see you in the next video. Bye.